Okay, this is the last part of the summative practice test solutions. Um, Again, we hope this helps. Remember, what we're always trying to find is what makes two ratios equivalent. And there's different ways of doing it. Equivalent fractions, unit rates, cross product. So let's continue. And on this problem, here's solve. So we have a proportion and we're being asked what value makes this true. So if I simply did the cross product straight away, I would have, I'm going to write it over here real quick, 5 over z equals 17 over 34. I would have 17z equals 5 times 34. And I would need to divide both sides by 17. And z, now I'd have this to simplify.
Do you even bother looking at this?
On this, so in this problem, I can multiply 5 times 34 and divide by 17. I could divide 5 by 17 and then multiply by 34. Or 17 times 2 is 34. So if I simplify this right here first, I would have 34 divided by 17 is 2. And z equals 10. Well, that reminds me that if I can simplify things first, I should. And if I simplify here, this becomes 5 over z. Since both of these are divisible by 17, that's a z there. This becomes 1 over 2, or 1/2. So now I have z times 1 is z. 2 times 5 equals 10. So remember, if you can simplify first before you solve and compute, it always makes for less work. Here, looks like I'm just have to do the cross product directly. So 4 times n is 4n. 5 times 3 is 15. And divide both sides by 4. And equals 15/4. That's fine. I suppose I could write it as a mixed number. 3 and 3/4. Either one of those is fine. I would recommend avoiding decimals. Just leave it as an improper fraction. The cost for 3 different candy options, I guess option A, option B, option C, are shown on the graph below. Okay, there's option A, here's option B, here's option C. For each option, explain why the option shows a proportional or non-proportional relationship. So let's do a little color coding here. We'll make option A this orange color, and this is non-proportional. So, and why is A non-proportional? Option A is non-proportional. Because the relationship between cost and candy, or actually the relationship is non-proportional because the graph does not pass through the origin. Or 0, 0, right? If it's proportional, it's got to be a straight line that passes through the origin. Where option B is proportional. That is, cost in candy, and the ounces of candy is proportional. Because the line, because the line is straight and goes through the origin. Goes through the origin. That is, remember the origin is 0, 0. Option C is also going to be proportional for the same reason as B. Because the graph on the line is straight and goes through 0, 0. Remember, so graphically, we know it's proportional if the line is straight and it goes through 0, 0. Option A is the only one that doesn't go through the origin, so it is not proportional. So each food ticket at the dance costs each food ticket. So food ticket costs $1. The price to get into the dance is $4 per person. Okay, that sounds like a dance, right? You pay one price to get in. Sometimes they charge you for food. So to get into the dance, Larry, Moe, and Curly go to the dance together. Larry gets 2 tickets, Moe gets 4 food tickets, and Curly gets 5 food tickets. How much did each person spend at the dance? Fill in the table below. Label the x-axis and y-axis to match the data. Plot the points in the graph and determine if the relationship is proportional or non-proportional. Explain why in a sentence. Okay, that's a lot of stuff to do. Let's take it one at a time. So Larry, I'll go like this. Here's Larry, here's Moe, and here's Curly. So Larry gets 2 food tickets. Moe gets 4 food tickets, and Curly gets 5 food tickets. So the total cost, so for Larry, it's going to be the $2 for the food plus the 4 to get in. For Moe, it's going to be 4 plus the 4 to get in. And for Curly, it's going to be 5 plus the 4 to get in. So Larry spends $6, Moe spends $8, and Curly spends $9. So I filled in the table, right? How much did each person spend at the dance? So here's how much they spent. All right, so how much did each person spend at the dance? That's this right here. Fill in the table below. Label the x-axis and y-axis to match the data. Well, how much they spent is going to depend. This is going to depend on how much food tickets I buy. So this is going to be on the bottom here. That's going to be food tickets. TIX, food tickets, and here is going to be how much I spend or their cost. So let's plot these points then, because that's what it said to do. It said to plot the points on the graph. So plot the points on the graph. So 2 tickets runs $6. 4 tickets runs $8. And 5 tickets runs $9. So I've got my points. Now what I want to do is I want to draw a straight line through these and see what it looks like. And then the last thing it said to do here is determine if the relationship is proportional or non-proportional. Explain why. Well, I see I have a straight line, but it doesn't go through the origin. So the relationship between cost, that's my one thing I'm counting, and the number of food tickets bought is non-proportional because, what's the reason? Well, the reason the line does not go, the graph of the line does not pass through 0, 0. Remember, it has to go through the origin in order for it to be proportional. So again, this is another way we've determined if things, if ratios are equivalent. So this point 2, 6, we can see it's not going to be equivalent to this point here, which is 5, 9, or this one here that's 4, 8. Because if we check them and we did 6 over 2, this would be 3. But if we did this one here, we did 8 over 4, that would be 2. So we can see they don't simplify to the same thing. And that's one of the other ways we've tested to see if things were equivalent, is when you simplify the ratios, they have to be the same in order for it to be proportional. These don't simplify to be the same thing, these 2 points. So we can see that's non-proportional, as we can also see with the graph. Well, I hope this helps.